Welcome to this video lecture on scientific research and information system. This video lecture is based on the book Scientific Research and Information Systems, a beginner's guide available in second edition from Springer, via Springer, Amazon and other booksellers. This set of video lectures is particularly about Chapter 7, Scientific Ethics, and this video lecture that you're watching right now is about Part 2, Fundamental Principles of Scientific Ethics. In this video lecture, we will discuss 6 fundamental principles of scientific ethics. The key goal of scientific ethics is to maintain the maxims or principles of honesty and integrity in all stages of scientific conduct. That means in all aspects and processes of scientific activity, such as study design, experimentation, education, data collection, analysis, reporting, review, and so forth, but also, of course, in, adjacent or secondary activities around this, such as research funding or staffing of research team. So honesty and integrity are really the fundamental maxims or higher order values, higher order moral values that govern scientific conduct, and they are operationalized in 6 different principles. The first of these principles is the notion of scientific honesty, meaning the pledge or the obligation of scientists to not commit scientific fraud through fabricating data or altering data, which is also called fudging, trimming, cooking data, or of course destroying or misrepresenting data. So in other words, to honestly collect, analyze, report, store and disclose data or other types of scientific information and evidence. There are ways in which this is being checked, if you want, or validated or assessed. One modern, very widespread, and sort of popular means of watching over scientific honesty is through this notion of retraction. Now, we covered retraction in the first video lecture. The idea of retraction is that if a scientific study has been conducted and has been published, even after the fact, after it has been published, it can be retracted, meaning that sort of like taken away from the body of knowledge. Sort of destroyed, if you want, except that you can't really destroy it, or you can't even unpublish a scientific study. Think of an article in a magazine where the idea would be to rip out these pages. Of course, you can't do that. And in an online world where much of the scientific activity and outcomes are reported, on web pages or as PDFs or online books and stuff like this, you can't really publish these things or delete these things. You can retract them, which usually means that there's a notice or a flag or some sort of comment on it that says that this piece of work has been retracted because of scientific dishonesty, which typically means proof that the data was fabricated, destroyed, trimmed, cooked, otherwise altered with. One non-for-profit sort of scientific organization that does this is a initiative that's called Retraction Watch. They have a blog post, retractionwatch.com, that reports, summarizes, and lists all sorts of retractions of scientific papers and related topics. I put in one example here, which is from last year, so 2024, where a paper got retracted from 2021 that purportedly claimed that acupuncture is a self-administered sort of relief for soldiers on the battlefield, which later has been found to be untrue and invalid, and so it was retracted, and the Retraction Watch reported that. These types of scientific honesty and retractions, some of them get a lot of attention in the media. A very recent and still ongoing case is that of data collator versus Francesca Gino. Francesca Gino is a professor in business at Harvard University, and by coincidence or not, she's actually studying honesty in business, and she's quite famous. And there is a team of scientists, and they call themselves data collator, and they're disclosing who they are. They're not anonymous. And they have reanalyzed some of the data from Francesca Gino and co-author studies, and found that the data from the studies must have been must have been fabricated, and it can't possibly be correct. And this has led to a entire series of events, including lawsuits, both against Data Colada, against Francesca Gino, against the Harvard University, and there's a very good episode on this and on the Freakonomics radio podcast that I'm linking to here, Why Is There So Much Fraud in Academia, that takes this instance but also talks about other cases of scientific dishonesty and the work that is being done by Retraction Watch, Data Collator, and other types of organizations and initiatives that are looking at whether or not scientists fabricated, trimmed, cooked, falsified, or otherwise altered scientific data. Very importantly, this process is still ongoing, so it's not conclusively proven what has happened or who's at fault. And this is very common to these types of cases. They essentially become very long lawsuits where one party tries to disprove the claims by the other party. If you Google that case, you will find out what the latest is. A second principle that we need to talk about is carefulness. So the obligation or the moral duty of scientists to avoid careless errors and sloppiness in all aspects of scientific work. Now, the main principle by which this is operationalized is through the academic peer review process, meaning that any scientific study, before it gets published and released into the open, disclosed to the world, it undergoes the so-called peer review process, where an author, a scientist, submits their article describing their methods, their procedures, findings, and outcomes, and it's handled by a so-called editor who invites a number of peer reviews, so other scientists, peers, that also know the specific area of content that the manuscript is about, and they review it and sort of go through a quality assurance process to make sure that the methods are acceptable, the findings are robust, the conclusions are believable, and it doesn't look like the data has been fabricated and so forth. There's nothing wrong with this. This is the quality assurance process, and just to give you a sense for this, typically an article before it gets published gets reviewed by anything between 3 to 5, 6, 7 people, and it takes, depending on discipline, journal, and so forth, it can take anything from half a year to several years. In information systems, many of the so-called top journals, they have review processes that take 3 to 4 years. So this is a very, very strict, very rigorous process to implement the notion of carefulness, so that we can make sure that whatever does get published and does get accepted for publication, disclosure to the world, is in fact careful and not not flawed or sloppy in any way. A third fundamental ethical principle is the idea of intellectual freedom, meaning that scientists should be free to pursue new ideas, criticize old ideas, and conduct research on anything they find interesting. This is a fundamental ethical principle for scientists, that they are trained and educated and sort of got to where they are so that they can research anything they find worthy researching without anyone telling them what to do or what not to do. The main principle by which this gets implemented is the so-called notion of tenure. In German, it's called Verbeamtung, which means that scientists at universities at some stage can get an indefinite appointment that can be terminated only for cause under extraordinary circumstances, and that's the key part. You basically cannot be fired from your position unless there's really extraordinary circumstances, and then the proof would be on the university to show that there are really extraordinary circumstances. And this indefinite appointment usually comes with a lot of material benefits. Germany has most people would say, one of the strongest systems of this tenure system, the Verbeamtung. You get a salary, you get a health cover, even for your kids. You get a very good pension. You do get rooms at the universities, you get assistants, you get staff, you get a budget, all these sorts of things. So basically all the equipment that you would reasonably need to do research without having to rely or ask for anything else. So the very idea in Germany and in other places is to safeguard academic freedom for all who teach and conduct research in higher education. So the basic idea is that you don't have to worry about material things. Your income, you could even say your wealth, your pension, the safety and health of your kids or your family. So you don't have to worry about these things. So you don't have to go and seek jobs or missions or projects from third parties in order to secure the material interest that you might have for you and your loved ones. And instead that you have a condition that you can pursue research and innovation free from any pressure, from any other party, from political pressure, but also from corporate pressure. So this is a very strong law. This is a very strong principle, and it usually in countries like Germany, it is very strongly anchored in laws and the way that the profession is run. This is not the case in all places. I was working in Australia that also has a tenure system, but you can still be fired and you don't get that much enabling conditions or sort of resourcing around you that you would get like here. Also, this entire protection is not without criticism. Yeah, here in the University of Hamburg where I teach, there's a very famous incident that there is one of the appointed tenured professors here is Bernd Lucke, and he was one of the main founders of what is now called the German right-wing extremist party, AfD, for which there is quite a bit of a public outcry and outrage about this. Now, I should say that he's actually no longer a member of that party, but he used to be. And it has led to people demanding that he'd be fired and that he shouldn't teach and he shouldn't do research, etc. and so forth. And I'm putting 2 links here, and they will show you that the university literally protected their employee and said, like, no, he has an indefinite appointment. He's a tenured professor at a university. He has the right to teach and conduct research how he sees fit. And you will all have to tolerate them. So literally this meant, for example, for him that because he had massive protests against him, that he had police escort and police support to guarantee his literally physical safety. And there are multiple such instances that you can find. The 4th principle we need to talk about is the principle of openness, meaning that scientists have an obligation to share data, results, method, theories, equipment, findings, and so on to the public. Anything a scientist does has to be made publicly available knowledge. Not secret knowledge, not knowledge for a particular company, then that would be research, but it wouldn't be science. Yeah? So we have an obligation to publish openly and be open to criticism and be open to the fact that we might be wrong and other people would can criticize or even disprove the work. One modern instantiation of this principle is a movement called Open Science, which is the basic idea, and here's a YouTube link which gives you a 5-minute introduction to it, which is quite interesting, very nice, you can watch it. The basic idea, sorry, I'm stopping this video here. The basic idea in Open Science is that you use online platforms such as the Center of Open Science or the Open Science Framework, osf.io, to register your study, your idea, your hypothesis, your data, your measures, and even your paper drafts. So and here's a few examples here from projects that, for example, I have registered, where you can see different versions of a paper, you see different hypotheses that we had at some point in time, and even data sets of studies that we've done at some stage. So everything is put out into the open, registered with a timestamp even, so that you can even see when this data, or even when the idea, when an hypothesis was being made and being registered and disclosed openly, in this particular case, even before the data was collected. Very importantly, this openness means that once you put things on these open science servers, you can never take them down again. You can't delete anything. The only thing you can do is add a new version on it. So it all comes with a versioning system, but it's impossible to retract or delete anything that you openly declared. You can sort of see this in the middle picture here, where this is an open science paper server where you can register and sort of upload different versions of the paper. And you can see here that from this particular paper, there are 9 versions uploaded, 9 versions. The latest one was the one that actually got published at some stage in the journal. And the other ones are there as well from different points in time. They all have a timestamp, and you can't delete them anymore. right? So the idea is that you always disclose what you're up to, what you're thinking, what you're doing at a given point in time, and then later you can update an updated version, you can upload an updated version of your thinking or your data or your results, but you can't take them away. So this is an implementation of this principle of openness and sharing basically anything that you're up to at any given point in time. The next principle is what's called attribution of credit, which means basically you should give credit to collaborators where credit is due, and you should not give credit where credit is not due. One famous way in which this plays out is in this notion of plagiarism. Plagiarism is a form of ethical misconduct where scientists take an idea or an outcome or even an argument, like a sentence, a statement, from other scientists without properly attributing credit. In this particular case, without citing the source. That's called plagiarism, and that is something that is forbidden. Because if credit is due for a claim, for an argument, for a finding, for an idea, we need to give credit, which in writing very often is done through these citation practices, where we basically insert a reference that links to a document or a paper or a book or anything else by some other person, whoever came up with this point or the idea. Yeah, we cite studies for findings, we cite theories for ideas or even assumptions, we even cite other people for criticism that they leveled at some other works, and we need to do this. And if we're not, then we are called that we're plagiarizing, because then it looks as if it were my idea, my argument, my finding, etc., if I'm not attributing the credit to where it is due. Again, you can find multiple ways in which this is being implemented. A typical one that students also know is our plagiarism checker, like the one by Grammarly. You can use generative AI these days for these sorts of tools. There's also tools such as Turnitin, which are plagiarism checkers. So what they basically do is they take written statements in your paper or your thesis or your essay or anywhere else, and they see if the way that you frame something matches published work somewhere else. And if so, then that you may have inadvertently or advertently, should have cited somebody else. The second link that you can see here is a Wikipedia entry. This one is in German. I'm not sure there's the same in English, but basically this is a list of people in Germany, public people or public figures in Germany that hold a PhD, so that submitted a doctoral dissertation at some stage, that have later been found out to be plagiarized. So many of these are actually, people from the political sphere, so like ministers. Karl Theodor zu Guttenberg, we mentioned in the first lecture, he's a defense minister. Franziska Giffey, she was, I think she was the mayor of the city of Berlin. Annette Schavan was actually Minister for Education and Science. And they all later have been found that in their own research, which they did to get a PhD degree, a dissertation, they actually were found to plagiarize content from sources where they didn't give appropriate credit. And in many of these cases, these people had to got their degrees revoked, they had to step down from position, etc. So this is an example of the attribution of credit. And the sixth principle is called public responsibility. And it states that scientists must or should report research in the public media, not just to other academics, whenever the research has an important and direct bearing on human happiness and after it has been validated by peers. Now, this has two particular aspects to it. So one of them is this duty of the obligation of disclosure, not just to other scientists in our scientific journals and so forth, but if it's relevant research that is directly, immediately relevant to a certain topic, you do have a duty of disclosure, which very often is done in reality in that universities tend to have sort of a public relations department whose job it is to go through the research that's being done at the university, and if it's relevant to whatever goes on in society, then they do so-called scientific press releases, which are basically like one-page descriptions of the research and the findings, and they put it on a server where all the media companies, so that means televisions, radios, and so forth, they basically scan these all the time and see if there's a really interesting piece of research they want to publish and talk about in their respective media format. Yeah, so University of Hamburg has that as well. There's basically a news department that shares research by members of the university, and then newspapers like Zeit, The Times, Hamburger Abendblatt, and other sort of local and national, international media stations. They pick up on these releases, and in case you do have an obligation of talking with them, you can't say no, basically. The other important part to this principle is this should only happen after the research has been validated by peers. So after the peer review process, not just when you've done the research, but only after it has been quality assured by your peers. And here I'm bringing an example where this principle had been altered for a little bit during the COVID pandemic between 2020 and 2022, because at that time, society basically decided to sort of take this requirement of peer validation out of it. At that time, they were so interested in the latest research on the virus and on vaccines and ways of mitigating and protecting against COVID, that they allowed, and they basically said, like, you should disclose everything as soon as you've done it. We're not waiting for the outcome of the peer review process. Now, I told you it usually takes a year, it can take multiple years, and they said we can't wait that long. We should actually look at it right now and to determine whether it's relevant and important. This is interesting in the sense that normally this quality assurance has been done by scientific peers that know methods and findings and know what it would say. And now this need to evaluate and validate which is good research, which is bad research, which still happens, of course, was basically shifted to the audience. That could be journalists, but ultimately even the world, who had to make up their own mind which of the studies is good, which of the studies is trustworthy, robust, reliable, and so forth. So it was a very interesting period because yes, it was more timely and quick, but also a lot of false studies and false claims and misinformation, inadvertently produced to science, also got out and got spread into journalism, media, social media, public media, official media, not so official medias, and so forth. And that created all sorts of other complications, because science is not always correct, and science is making lots of mistakes. Yeah, so we are coming up with breakthroughs at some stage, but we're also producing a lot of no results and bad results on the way. And if you're interested in this is an interesting article about this, published in Nature, that looked at how this idea of public responsibility under the extraordinary circumstance of the COVID pandemic, where they altered this ethical principle a little bit, and how that played out. And this brings us to the end of this video lecture, where we discuss 6 fundamental ethical principles for scientific research. Thank you for watching, and thank you for listening.